The length of a rectangle is 6 more than 3 times its width. The area of this rectangle is 144 centimeters squared. Find the dimensions of this rectangle. I'm going to start by drawing the rectangle and trying to label the sides using variables. If I read the first statement again, I realize that I know more about the length than I do the width, so I'm going to choose width to be my variable. If W is the width, then the length is 6 more than 3 times W. 6 more than 3 times W. This is my rectangle. I know the area of this rectangle is 144. Well, how do I find area? I multiply length times width. Length times width equals 144. This now I'm going to focus to solve this equation. I'm going to distribute first. And now I realize I need to factor to solve. I need to subtract 144 from both sides. And then factor. First I will take out the common factor of 3. And then use the coefficient of 1 rule to factor the rest. What two numbers multiply to be negative 48 and add to be 2? Negative 8 and positive 6. Nope, positive 8 and negative 6. I need this to be a positive 2, so the 8 is bigger. Using the zero product property, W plus 8 could be 0, or W minus 6 could be 0. That means W could be negative 8, or W could be positive 6. But let's go back to the original question and see if both of these could work as solutions or if just one. So up here, let's rearrange a little bit. The length of a rectangle is 6 more than 3 times its width, and the area is 144. Find the dimensions of a rectangle. Now I figured out that the width could either be negative 8 or positive 6. But if I'm thinking about width of a rectangle, I cannot have a negative. So this value is out. So 6 seems to be what my width is. Let's go back and find the dimensions now. So the dimensions then, if this is 6, 3 times 6 plus 6 is 24. So my rectangle is 6 by 24, and I believe that the labels were centimeters. 6 centimeters by 24 centimeters. Find the dimensions of a rectangle whose perimeter is 46 and whose area is 126 meters squared. Now, if I try to draw out and label like this, the dimensions of this rectangle, I really don't know anything specific about the length and width, except that I know that the perimeter is 46 and the area is 126. I really need to use these two facts in order to write my one equation. But to start off with, I'm going to use this perimeter to try to figure out expressions for my variables. For example, if I label this W, I want to be able to write the length of this rectangle also using W. Because if I don't, then I'm just going to have an equation that has two variables in it, and I cannot solve it. So the key here is to, right now, we're going to call it L. And try to come up with a way to write L in terms of W. In order to do that, I'm going to go back to my perimeter equation, and I know that L plus W plus L plus W is 46. And I'm going to try to simplify this down and solve this perimeter equation for L. Well, if I combine like terms, and then I want to, again, solve for L, so I'm going to subtract 2W from both sides. So 2L equals 46 minus 2W. Finish solving for L by dividing by 2. That means L is equal to 23 minus W. Now I have an expression for L that I can use in my original rectangle up here. So instead of these L's, I'm going to write 23 minus W, 23 minus W. All of this work here is not the solution to the equation. All of this work was just necessary to be able to write the dimensions of my rectangle using only one variable. Now that I have the dimensions of my rectangle using only one variable, I can use this other fact about the area to write my final equation. Area is length times width. My length is 23 minus W, and my width is just W. I know that the area equals 126. This now is an equation that we've been dealing with in class to figure out how to solve. I'm going to distribute backwards. And now I want to use a zero product property to solve this. That means making one side of this 0. And I'm actually going to move everything over this way because I want to get a positive coefficient in front of my W squared. So I'm going to add W squared to both sides. So I have 23W equals W squared plus 126, and then subtract 23W. So 0 equals W squared minus 23W plus, 126. Notice when I wrote my terms over here, I wrote them in order from highest power to lowest power. Now I need to figure out how to factor this to solve. The two numbers that multiply to be 126 and add to be negative 23 are negative 14 and negative 9. Therefore, when I solve this equation, I know that W will be positive 14 or positive 9. Let's see what that means for our solution to the original problem. So the original problem, remember, was talking about a rectangle whose perimeter is 46 and area is 126. I get that the width could be 14 or the width could be 9. So let's go up to our original rectangle. We found 14 and 9 as our solutions. If W is 14, that means that the length is 23 minus 14, which is 9. It's interesting because it's the same solution we also got before. Remember, it doesn't matter what I define as length and width. It just means that 9 and 14 are going to be the dimensions of this rectangle. So I am done here. I know that my rectangle is 14 meters by 9 meters. I can easily check to make sure that this works because if I multiply these together, I should get the area of 126. And if I add these together, length plus width plus length plus width, I should get 46. And I do. The sum of two numbers is 25, and the sum of their squares is 113. Find the numbers. So I'm talking about two numbers here, and I'm not going to pick two different variables. I'm really just going to pick one. So one of my numbers is n. If one of my numbers is n, and together this number plus the other number equals 25, then 25 minus n would be my second number. Let's think about that for a second. If I know two numbers that add up to be 25, and let's say one of them is 7, I know that the other number would have to be 25 minus 7, or 18. So to find, if I know one number, I would subtract it from 25 to find the other number. That's why I set up my variable expressions in this way. So these are my two numbers. The more important part of this is that I know that the sum of their squares is 313. So that means if I square the first number and square the second number, I should get 113 when I add them together. This now is the equation that I want to solve. Now in order to solve this equation, I need to multiply this entire term out. So I have my n squared from above. This is going to be, if I FOIL it, 625 is the first, outer, inner, last. Combine a whole bunch of like terms over here. I'm going to have 2n squared minus 50n plus 625. In order to solve this equation, I need to get one side to be 0, so let's subtract 313. 2n squared minus 50n plus, what is this? Now, in order to factor this, I'm going to first take out the common factor. Continue to factor. I'm looking for two numbers that multiply to be 156 and add to be negative 25. I believe I'm looking for the numbers negative 12 and negative 13. That means my solutions to this equation, well, this isn't a factor that has a variable in it, so I'll ignore that. N could be 12 or n could be 13. And since I'm looking for two numbers whose sum is 125 and their sum of their squares is 313, these two numbers happen to be that. My solution here is 12 and 13.